Okay, welcome back. Today what we are doing is law of sines. Law of sines. Okay. This rule will be useful for us to solve many, I would say about 70% of all triangles that we see that are not right triangles. Again, maybe about 70% is one of our most popular ways of solving when it's not a right triangle. Okay. So the rule goes like this. It says if you have a triangle and you're given, we'll talk about some parts. We're given, let's say, an angle. Let's say this is 23. We're given a side, call this 10. And we're given anything else. We can give ourselves an angle or side. I'm going to give myself let's give myself an angle here. Okay, 100 degrees. With this rule, it says I can solve this triangle. Now, let's label this A, B, C, capital A, B, C. So I am given little a, I am missing little b, I am missing little c, and I am missing big C, right? I don't know what that angle C would be. So given the information, we have measurement angle A, measurement angle B, measurement angle C, side A, side B, side C. These are angles. These are sides. Remember, every triangle has 3 sides and 3 angles. We know half this information. We know 1 angle, we know 2 angles, we know 1 side. So we talked about before, if you give me 3 bits of information, 3 out of 6, you can always be guaranteed to solve for this triangle. We can always find out the rest of it. We can dox it. So first things first, what do you think would be the easiest thing for me to solve for? Well, since I have 2 angles, we can find the third. All angles in a triangle add up to 180. So 23 plus 100 plus, call that C, or let's call C, is equal to, maybe big C, is equal to 180 degrees. 123 plus big C is equal to 180. Subtract 123. C is equal to 57 degrees. So automatically, I'm starting to solve for some things. And this isn't necessarily the new rule. We're just using rules that we learned way back in geometry. Okay. Now we're still missing the sides, B and C. My first question is, can I use a right triangle to solve this problem? Can I use a right triangle to solve this problem? And right now, answer is no. Okay. Answer is no, I can't use it. So we're gonna jump off, or we're gonna try our new rule today. And our new rule is called law of sines. Let me go ahead and write that. We have 2 ways of writing it, 2 different versions. We have one where we write sine of A over little a is equal to sine of B over little b, okay, which is also equal to sine of C over little c. The alternate form for us is going to be A over sine of A is equal to B over sine of big B is equal to C over sine of big C. So law of sines is this. It's just the angle over the side or the side over the angle. Angle over the side or the side over the angle. So it's actually the easiest thing for us to memorize. Now, are we always going to use all 3 at once? No, we never use all 3 at once. So when we're doing a problem, you make a choice. Are you going to use these 2? Or we can use these 2. Or you can use these 2. So you're going to make a choice on which one you want to do. So what's the difference between last week and this week? Last week, all our triangles were right triangles. This week, none of our triangles are going to be right triangles. So that's a big step, like off a cliff. Okay, so here's our rule. Let's see, the way we solve this problem is we will always pick what we want to solve for first. So give me 1 second. So for my triangle here, what do you want to solve for? You want to solve for, oh, well, we solved for C already, so we don't need to solve for C. So you have a choice, solve for B or C. B or C. Okay, so let's just pick C here. Okay, let's pick C. So C is right here. We're going to use this guy. And then pick a pair that you know for sure. So if we look here, don't we know all of A? We know angle A and side A. And that's our first hint. To use law of sines, you need an angle side pair. We put a star here. Angle side pair. What I mean is you need to know both an angle and its corresponding side. So do we know the angle and side for B? No, we're missing the side. Do we know the angle and side for C? No. Do we know the angle and side for A? Yes. So this is one of our main hints. We can use law of sines if you have an angle side pair. I want to show you guys in the triangle, how would you see this in the triangle? Do you have an angle side pair here? We do. We can use law of sines. Do we have angle side pair here or here? Nope. But as long as we have one side pair and angle, we can use law of sines. That is your first hint. If you remember that, you will always know when to use law of sines. Now, we said we know our A's and our C's. Let's set this up. So here is my hint how to use this. First, write down what are you planning to solve for. We said let's solve for side C, right? C over, looking over here now. Hey, if C is on top, let's use this one over here. Over sine C is equal to, what do we know? We know about A, don't we? So this is equal to A over sine A. Right? So please take a look at how we set this up. You must set this up when you first start. Do we know C? No, we don't. Do we know angle C? Yes, we do. Do we know side A? Yes, we do. Do we know angle A? Yes, we do. So if you look at what I did here, I ended up plugging in everything that we knew and what we didn't know. And it turns out we only have one variable left. Now we can solve this like we did in Algebra 1. That's all for C. The way we get rid of this sine 57, since it's on the denominator, we can multiply it to both sides. Or multiply this to both sides. Sine of 57 to both sides. Sine of 57. And we're left with C is equal to 10 sine 57 over sine of 23. Okay, on my calculator, I'm going to type it as I see it. 10 times, I don't hit sign first. On my cheap calculator, I always have to hit the number first, 57. 57 sine equals divided by 23 sine equals. And it's telling me my side is 21. That makes sense. Yeah. So C is 21.46. That's the side C. let me go ahead and try this one more time. Let me write it for you. On the calculator, I'm going to write 10 times 57 sine equals, that's going to mix the top all together. Then I'm going to hit divide by 23 sine, and then equals again. You have to practice that so you're really good, so you don't waste any time on the test or even on the ACT on trying to remember how to plug this into your calculator. Okay, let's try this again. I'm going to write 10 times 57 sine equals divided by 23 sine equals, yep, 21.46. So now we know what side C is, 21.46. Let's do the same step now for side B. Okay, B over sine B is equal to A over sine A. How did I know how to set this up so quickly? Okay, remember the rule I said. Write down first what we don't know on top. So I just wrote down side B, because that's what I'm solving for. Then if I'm writing a side on top, I have to write the angle on the bottom. I have to follow the same pattern for the other side. I know A, and I know angle A. Okay. Let's go ahead and plug in what we know. It's B over sine. We said B was angle 100 is equal to, you can start with whatever side you want, but I'll have a hint for you later when we start coming up with issues about which one to start for first. Okay. And then, let's finish this. A we said was 10. I think it was 10, right? Oops. No, sorry. But yeah, it was 10. 10 over sine of 23. Again, we know 10 and 23. 10 and 23, because this is what we started off with. Okay, looking at this problem now, I'm solving for variable B. So back from algebra 1, opposite of divide is multiply. So write sine of 100 to both sides. And we're left with B is equal to 10 sine of 100 over sine of 23. I want you guys right now to try to plug this in your own calculator and see if you're going to get the same answer I got. Okay, so go ahead, practice on your calculator, take it out. If it's on your cell phone, it's on your cell phone, or if you have a scientific calculator, get that out. Okay, I'm going to go ahead and type it the way I see it. 10 times 100 sine equals divided by 23 sine equals, I'm going to decide 25.20. On top, my B is 25.20. So let's go and look at the triangle. 25.20, and we said 21.46. So my triangle isn't drawn in the most accurate way. Does that look like a 23 angle? Does that look like it's too big or too small, right? But besides that, I want you guys to double check this way. Small angles mean small sides. Big angles mean big sides. Let's see if that kind of worked out for this problem. So always start with the largest or smallest angle, just pick a side. If my largest angle here is this side opening the largest side, yes, 25 is a lot bigger than 21 or 10. That might be right. Looking at angle A, see how a small angle means a small side? Yeah, 10 is my smallest side. And 57 is my middle angle, and 21 is my middle side. In the last answer, when I wrote 25.20, it really depends on what the test tells you to round off to. When it comes to inputting on the computer, I would say, if it's a round off, you should write 0.20, 25.20, if it's rounding off. Yeah, the question is, can we just check the opposite sides angles? Yeah, that's just a quick way to see if I'm totally off. Because sometimes we make simple mistakes. And on our practice yesterday, some of you guys made the simple mistake of giving a large angle to a small side. You're like, oh wait, that can't be true. Just on the side, let me rewrite this. I want to show you guys, you tell me if this makes sense or not, okay? Imagine if I accidentally wrote it as 25 over here and 21.46. Would this make sense? Largest angle, is that my largest side? It's not. So you can see, oh, I just made a dumb mistake. I just flipped the numbers around. It's just a quick way for you to just double check so we don't like get points off wrong for something that we did right anyways. Okay, let's do this again. Let's do another problem. Okay, let's come up with another example. Call this 98 degrees. Call this over here 27. Okay. And we're gonna say this side here is, let's do this one, yeah. Call this 5. Okay, 5. A, B, C. So just right now, as we start off this problem, I want to make sure you guys can see all labels. Measurement angle A, measurement angle B, measurement angle C, and then we have side A, side B, and side C. Do you have to write these out for every problem? Please don't. It's a waste of your time. I'm just writing out so you can see what we have and what we don't have. Sure, Oswaldo, I'll do it for this problem after we're done, okay? So angle A is 27. Angle C is 98. We do know side B is 5. Now, do we have any angle sides pairs here? I said angle side pairs because if it's angle side pair, I know it's law of sines. 27, I don't know the side here. 98, I don't know what the side here is. B, I don't know the angle. So our first guess is that maybe I can't use the law of sines. But some of you guys might be screaming out right now that if we have two angles, can we find the third? We can. So 27 plus 98 plus B is equal to 180. So B has to be, this is 125 plus B is 180. So we're looking at B is 55 degrees. Okay, 55 degrees. Hey, now if I write 55 here, you can see I have an angle side pair. Or looking at the triangle, you'll see that I have an angle side pair. And here's what it is. If you have an angle side pair, we can use law of sine. And we had to do some work to get there, but we were able to get there. Not everything is just given to us. Sometimes we have to work a little bit. So at least I found all three angles. Now we're going to find all three sides. So let's label the sides, little c and little a. Now you tell me which side do you want to solve for first. Right now, we're going to say it doesn't matter. You can solve for any side first. So let's solve for side A. Now we have a choice. We can write sine of A over little a, or A over sine A. If I'm solving for A. So I'm going to choose this guy. And part of the hint is that I don't want the variable on the denominator if that's what I'm solving for. I prefer to write it on top. So my gimmick when I set up these problems is always first write what I want to solve for, and then fill out the rest of the problem. So A over sine A is equal to, now what else do we know? We know that B, an angle B, that's 5 over sine of 55. I don't want to use I don't want to use C because I don't know anything about C. I just know the angle, but I don't know the side. So once I fill this out, you realize I only have one variable. Let me change one part of this. We know what angle A is, don't we? We know angle A is 27. All right, in this problem, to solve for A, to get we're going to multiply sine to both sides. A is equal to 5 sine of 27 over sine of 55. If you have a calculator, go ahead and write that out on your calculator. See what answer you get. Five times 27 sine equals, then we're going to divide 55 sine equals, I'm seeing 2.77. Do that again. Sine equals divided by 55 sine. Just to double check. Yep. Thank you. Double check your decimal, Brian. Thank you.
We're not rounding for that?
We are.
Oh, so would it be 7 point? Oh, wait, third number. My bad.
Yeah, that third number, if I'm doing two decimals.
Yeah, okay. Gotcha.
Okay, that's A. Bam. I'm almost done with my triangle now. Now, some people might say, Pisco, can you use Pythagorean theorem now? Is this a 90-degree triangle? Is that a right angle? No. So I cannot use Pythagorean theorem because it is not a right triangle. Pythagorean theorem only works for right triangles. That's all for side C now. So we got to start all over. We write C over sine C is equal to 5 over sine 55. Well, we know what C is, right? We know what angle C is. So just fill that out. That's going to be angle 98. Okay. And then C is equal to 5 sine of 98 over sine of 55. Sometimes you say, how come people are so much faster than I at like math problems like this? And honestly, it's because of practice. It takes a lot of work to be good at something. Okay, calculator work. Go ahead and try this yourself. If you don't know how to do it, make sure you're following me. 5 times 98 sine, because we're taking the sine of 98, equals, then divided by 55 sine. And you'll notice once you hit sine, you'll take the sine of 55. Then make sure you hit equals at the end. 5 times 98 sine equals divided by 55 sine equals. I'm getting 6.04. I could be wrong. For sure, I could be wrong. 5 times 98 sine equals divided by 55 sine. Yeah, 6.04. Yeah, please, Michael, please. There's probably some like dumb click. So when I'm rounding, because it's 4, this is less than 5. So we're going to round down. Okay. So not only is setting up the problem is kind of hard, using your calculator is hard. It's like that's why we have to practice this. Now the cool thing is that the answer is really from a calculator. 6.04. Now we solve for both angles and side. Okay, now we are going to go a different route here. And we are now going to go backwards and solve for the angle. Let's do another problem now. Let's draw a triangle. This is going to be a, let's see, 91 degrees. And then I'm going to give you side 10. And this will be a, let's do 9. Okay. A, B, C. So we're missing angle B. We're missing angle C. B, C, and we're missing side C. So we know nothing about C. Wait for us to check it without law of sines right now. Okay, we can check it later using law of cosines, but not as of currently. Okay, so let's go ahead and say what we know. Measurement angle A, measurement angle B, measurement angle C. A equals to B equals to C equals to. Again, you don't have to do this when you're doing the problem normally. I'm just writing out so you can see what I know and what I don't know. We know angle A is 91. We know side A is 10. Automatically, I know I can use law of sines. Same thing over here, law of sines, because I see angle side pair. Angle B, I don't know what that is. Angle C, I don't know what that is. But I know side B and side A, okay? I know side B is 9. I don't know side C. So as you can tell, I know only 3 bits of information, but that is enough for us to tell everything else about this triangle. So if you can't use law of sines, then we have law of cosines, okay? And that's something that we'll do next time. So we first start off to say, when we're solving triangles, is that a right triangle? Okay, great. If it is, do it. If it's not, it might be law of sines. And if it's not law of sines, then it must be law of cosines. That's like the order of progression, like easy, medium, hard. So right now we're at medium because we have angle side pair, law of sines automatically. So let's go ahead and ask ourselves, what angle side pair we know? We know for sure all of A's. So then you have to now pick what we don't know. And we don't know a lot. We don't know any C's, and we don't know this one B. So here's what I'm going to do. I'm going to pick the B, because at least I know side B, right? If you know her first name, you don't know her last name, at least you know part of her name, right? But if you know nothing about her, you'll never find her. So the way I start the problem is like what we said before. Write down what we don't know. And I don't know angle B, so for law of sines, we always write sine of B, because all angles have a sign in front of it. Do this one more time. See, all angles have a sign in front of it. So they always come in this set. So we write sine B on top over, what do I write on the bottom? We have to write, if angles on one side, we write sides on the other, is equal to. Now, you can choose the other ones. You could choose A or C. But remember, we know nothing about C. So you always write down the side that we know, the information that we know. Sine of A over little a. And the reason why we do that is because when I'm plugging in values, I do know what's B. I do know what's A. I do know what side A is. So we fill out everything except that missing B. If we had tried plugging in C, it'd be a waste of our time. We don't know anything about it. Just like before, we are solving for letter B. So to do that, let's get rid of the 9. Sine of B is equal to 9 sine 91 over 10. Now, I'm going to show you the algebraic work because we're trying to solve for b. We need to get rid of sine. That's sine inverse. Let me write this. You're going to write sine inverse to both sides. It's sine inverse to both sides. Now, I'm going to write it once so you guys can see it, but you actually don't need to. You would actually save time if you don't write it. B is equal to sine inverse of 9 sine of 91 over 10. So for this one, you have to know how to use your calculator, and you actually plug in this inside value first. 9 times 91 sine equals divided by the 10 on the bottom equals. Now, you have this number, 0.8998629, blah, blah, blah. But don't write that down. Don't write it. Go ahead and do the inverse of sine now. So on my calculator, on my iPad, there's a little button for it. And we worked on when we were solving for triangles, m.2, m.3. Remember how to do inverses? Sometimes you have to shift for some of your calculators. So I'm just gonna hit that. And a B is angle 64.14 degrees. Go ahead and try that yourself right now. And I'm gonna show you the faster way of doing this. Okay, hopefully you're able to get 61.14. If you don't, if you stick around after class for just a little bit, I can help you figure out your calculator. Okay, but I'm gonna show you another way of doing this. Just do that first. Don't waste your time moving sine over yet. We know that's gonna be inverse. We know it's gonna be a shift, but just type 9 times 91 sine equals divided by 10 equals. That's not a number we use. We're gonna shift that. So shift sine inverse, and you'll get the 64.14 that we're hoping for. Okay. All right, let's see. The angle is 64.14. Let's write that down. 64.14 degrees. Now, if I know this is 64.14, is there a way for us to find out our angle C now? Yeah. And since you have a calculator with you right now, go ahead. 61.14 plus 91 equals, then we're going to minus 180 from that. And now we know the other angle, 27.86. Try that again yourself. You have a 64.14 plus 91 equals, and we're going to minus that from 180. 64.14 plus 91 equals, minus that from 180. Oh, I made a mistake. This was a 4. That's not a 7. Are you guys getting 24.86?
Yeah.
Okay, my mistake for the first time. Cool. Now here's the cool part. Just now we solve for angle C. So doesn't that mean we can solve for side C now? So it's kind of giving us a path in which we have to solve it. So once we solve for the angle, we can go back and solve for the side. Let's go ahead and solve for that last side C. I'm going to write it in this little corner here. C over sine C, which is 24.86. Remember how I asked you to write what you don't know on top? That's going to make your life so much easier. No flipping fractions. Just take it as it is equal to what I know for sure, I know for sure A, 10 over sine of 91. I've done this 1,000 times already. 10 sine of 24.86 over sine of 91. 10 times 24.86 equals, whoops, I didn't sign it. 10 times 24.86 sine equals, divide that by 91 sine equals. I'm getting C is equal to 4.20. 4.20. Then we double check just because I have time. 10 times 24.86 sine equals divided by 91. Yeah, okay. Okay. So the cool thing is that regardless of the information you give me, as long as you give me 3 bits of information, I can solve for the rest of this triangle. But you need an angle side pair to get this to work. Oops. Yeah, 4.20 is correct. So let me give you some examples. And this does not work. So law of sines does not work. It doesn't work when I give you a side, side, side triangle. That does not work because you don't have any angle side pairs. No pairs, you can't do it. None of these work if I give you angle, angle, angle. No way to solve. You always have to give it a side to anchor it down someplace. If not, this could be oh my goodness. This could be a bigger version. So it's an A. If you guys remember triangle congruence properties way back in geometry, you have S, 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 A, S. You have angle, side, angle. You have, what was another one?
S.
Angle, angle, side. What doesn't work, so these all work. Okay, these all work. What doesn't work is ASS, because that's a bad word, and AAA. These don't work. Okay. But we're learning law of sines and cosines. This actually we can solve. But the reason why ASS doesn't work because it gives us 2 triangles. And we'll learn how to do that next time in class. It is a little bit tough to realize, but ASS, if you have a triangle that is angle, side, side, could give us 2 possibilities. And let me just draw that out for you right now. Angle, side, side. If I give you an angle that's say 32 degrees, and if I give you a side, side, so it's angle, long, short. What happens is you end up with a problem that you think that the triangle looks this way, like it has to look this way. But you go, I've always built triangles this way and I've never had any problems. So let me give you an example of that. If I told you this was 10 and 9, 10 and 9. But there's actually two ways to draw this triangle. The second way is actually this way. Why can't that be 9? Because if I thought this like as a circle with a radius of 9, right? That's a radius 9. Wouldn't this 9 touch the triangle at two different places? Kind of a funky way of looking at it. But this is why AESS didn't work. It's not that we weren't given enough information. With angle side, it gives us two possibilities. That's why this wasn't a rule you could use in geometry. So what we'll talk about in this next time, how do we solve for two of these triangles? One triangle will look like this, 32, 10, and 9. And the other triangle, oops, will look like this, 32, 10, and 9. And both these triangles are true. So which one do we pick? We have to solve them both. Okay? And that's something we'll talk about next time.